We're back, we're live, we're at Think Tech Talks here on a given Friday. We're talking about technology today. We have Ted Ralston, who's an aerospace consultant. We have Chuck Devaney from the UH Manoa School of Geography. We've had such a heavy representation from the School of Geography. I feel I'm getting to know everybody there. Okay, and Ted we know already because you know, he's been on a couple of shows talking about drones. In fact, we had a big panel at the Plaza Club a couple months ago, a very important panel, and a lot of people came to that to talk about drones in Hawaii. And today's show is entitled "Good News for Drones in Hawaii." Okay, and why do you think we called it that, Ted?
Well, the FAA has recently published its roadmap to the future, how we can get drones into the U.S. airspace. And it's a very complicated roadmap, but it's full of specified requirements for research. Until we're going to be able to get small drones under public aircraft ops into the airspace first, but anything beyond that is going to take an incredible amount of research.
Let's roll it back though.
Sure.
The last time we visited the subject, everybody was hanging on tenterhooks about what the FAA was going to do. Because, you know, I mean, you can explain it better than me, but because the FAA controls the airspace. And if we want to do drones, it's not like we can just send them up. We have to have the FAA give a blessing, and it's complicated, and it's, you know, it's important that we know what's in the airspace. It's not like Amazon or anybody else can throw drones in the air and let them fly. So can you give us the history of the FAA, you know, decision process, so we know what they were considering and how long it took them, and what they ultimately what they thought they were going to do, and then what they ultimately did.
That's a lot of stuff to talk about.
Take your time.
I'll just reverse that order, can I?
Okay, please.
What the FAA has is a long legacy and history of what's called see and avoid. And whether you're a VFR private pilot, you see and avoid. If you're an airline pilot, the controller sees you and gives you a block of airspace that's yours, and everybody else stays out of it. So it's all about separation by see and avoid, with some radio aids. What they've done in the world of drones is said the drones are going to have to follow through in that same exact style of operation. So if you're a drone, you will have to sense and avoid, since you haven't got eyes in the airplane. And some means of having an equivalent concept of sense and avoid, equivalent to the see and avoid, is what they're all about. Now just to do that there's no end of research required to get to that point, because we got a whole other piece in the loop. We got a ground station in the loop now. We got communications links we didn't have before. So the failure consequences are pretty onerous.
It could be death.
Yeah. And so
let me just understand see and avoid. So see and avoid is essentially an autonomous system where the drone has the ability to see anything around its airspace and make a decision about whether that's a threat. And of course, I'm sure the FAA has some ideas about what the parameters of that decision process would be. And then when it realizes, when it concludes all this is in software, that is a threat, then it takes certain evasive action to move away from the threat. And all this has to be programmed to work autonomously. Am I right?
And what you described is sense and avoid.
Oh, sorry.
See and avoid is the two eyeballs looking out the window and seeing what's out there and staying away from it.
Okay, but not going there in the first place.
Exactly.
Okay.
And what you defined is one component of sense and avoid with a high level of automation, but there's still a man in the loop. And that man in the loop is actually two. There's an operator on the ground who's operating the handheld unit or a ground station of some kind, and there's an observer who's observing the airplane in doing its thing. So you have two guys, not just one, and but they're on the ground instead of in the cockpit. And then of course you have communication links to take it back to air traffic in case you had a deviation from the intended path. You have to advise air traffic so they can close the airspace around or whatever they have to do to make it work. So what's going on here is the FAA is saying we're not going to change any of the existing regulations or rules. We're simply going to find a way that drones can be accommodated in that airspace. And the first level of accommodation is 55 pounds and less. And my hope is they get even more rational and find within that category even smaller units like the one sitting here on the table that don't pose any real catastrophic risk. But this is going to be...
That could hurt you. If you got in the way of those blades, you could get hurt.
In the sense of a massive problem in airspace, it's probably less than that. It's got 5-minute battery life, and it's got very limited exposure. So there's an exposure issue and probability issues and such. So anyway, we got this history of 70 years of see and avoid, and the FAA is not going to change anything. We're going to simply make them accommodate. And that's where the research opportunities are. And it's going to be in electrical engineering. It's going to be in circuit design, networks, computers, cognition. How do people think? How does this ground station guy, who's not in the cockpit, how does he get the picture as if he was in the cockpit and make decisions?
So are you saying that the FAA said, very nice, boys, but we're going to treat this as an airplane?
Exactly. And in fact, if you read this roadmap they've put out, some of the examples they brought 3 of them out that were interesting.
But before you get to the roadmap, okay, is the roadmap before or after the recent action?
They're separate.
Okay, so the roadmap came before.
Yeah, the roadmap is happening on its own.
We knew this a long time ago.
It's, about 2 years late to schedule.
Okay, so what's the roadmap?
The roadmap is, well, I have it here in the book, but it's...
you don't have to read the book. I mean, I don't know. What do you think, Chuck? Should you read the book?
From cover to cover.
Yeah, memorizing is a good idea. What it is a 3-phase approach, accommodation, integration, and then evolution, as the airspace will change to deal with the emerging issues of drones. But in order to protect the existing air management rules, what has to happen is a lot of technology has to be created so that unmanned aircraft can fit within the current rules. For example, if an airplane is told to he's number 3 for the runway and stay behind the company 7-3, well, the drone has to understand that. Or if he's given a clearance to 31,000 feet and then the controller changes it, I make that 33,000 feet. The drone has to be able to hear that.
Well, is it the drone that listens to the language, or is it the operator of the drone is listening to the
all
language?
of the above.
So it's just like talking to a pilot in a plane.
Exactly, right. Just like talking to a pilot.
Don't you have to be qualified as a pilot or a traffic controller in order to understand and act on that kind of thing?
The pilot on the ground, the pilot, the PIC, the pilot in command, has to be at a certain level of pilot training.
Is there a test?
Would be like the private pilot test. He has to be at least a private pilot, and the observer has to have gone through ground school, as I remember.
What do you think of that? What do you think of that?
Well, if I was the FAA, I'd be very proud of myself.
Suppose you were actually Ted Ralston.
If I'd say, we have a little different approach here that would be appropriate to bring into it. I'd start the thing not from preserving status quo, but thinking about this from a catastrophic exposure perspective, and think of what that means. Certainly a 737 operating autonomously has a lot of catastrophic consequences.
Hundreds of people die.
Yeah, or even if it's a cargo airplane, it still has all kinds of issues, 120,000 pounds of metal. But something like Chuck's helicopter here, or even the smaller ones we had last time, some of these are down to 1 pound. The catastrophic consequence of them is not measurable. Seagulls weigh 1.5 pounds. We certify the airplanes, commercial airplanes, to operate with an impact of 8 seagulls. That's 12 pounds of meat. And so the industry allows 12-pound impacts to occur, and everything has to be designed for that. So isn't there logic that says UAVs in that same weight category would be equally non-catastrophic? Now you have issues of how many at one time. Well, we don't control the seagulls, and so there's a different way to logic.
Can I offer a thought, and that is that if you're going to build the semi-autonomous software, to sense and avoid, is it what?
Yep.
For the larger model, why not just apply it across the board to all the models? You're going to have that. You're going to have it anyway.
Well, what'll happen there is the sense and avoid is going to have a lot of communication gear on board. It's going to have.
So it's weight.
Yeah, weight and power consumption would be the issues. Plus, if you're dealing with something like, again, Chuck's example here, or the smaller ones, they just don't have the projection. They don't have the range from the launch point to require all the electronic. So if you, to answer your question, a systems engineering approach looking at catastrophic consequences could deconstruct this problem down in a different way than what the FAA has done.
But this is what their
This is what it is.
Their roadmap says.
Right.
Okay, what else does it say without reading?
Well, again, the thing that really intrigues me, especially regarding Hawaii here, is that the research requirements are this thing's thick with this half of this thing is research requirements.
Yeah.
So if I was in the academic side of the house, I would be beginning to build up, use this to start setting up curriculum and set up programs that can in Hawaii here, let these software systems and cognation systems become developed here.
That's probably one of the reasons, not all the reasons, that Chuck is involved. But Chuck, you're in the School of Geography, not the School of Engineering.
No.
So why are you here?
Why am I here? That's a very good question, and I wonder that daily. No, I've been working with TED for, I guess, going on a couple of years, not so much in the development of the platforms, but their application. So I have had the opportunity to test a lot of these different platforms with different applications. So the latest one has been acquiring imagery for humanitarian assistance and disaster response, and it's become an actual very good application for these platforms. So last time we met here, I had just gotten back from the Philippines. So we're actually going back in about a week, and with the blessing of the local municipalities and government to bring in a little bit more sophisticated aircraft. This being one of them, but the thing about this thing is it's sophisticated and it's got a lot of capabilities, but it's also, because it's open source, and I'm sure Ted will be able to explain a lot of this better than I, but since it's open source, it's the cost factor then remains low, because we're sharing with a community of people, and the parts are cheap, and so you just have to take the time to get to know the platform a little bit more intimately. In return, you don't shell out as much money for the platform itself. So we can take this and build it in the field if we need to, repair it in the field if we need to. We can also, we're going to be dealing with nations that are developing, which don't have the means to acquire a multi-million-dollar aircraft or $100,000 aircraft for that matter. They can still benefit from something at this scale.
Okay, so this is this drone on the table. Is this the same drone that you had the last time?
No.
This is bigger.
This is bigger. It's got all the fully autonomous capability, about the same range as if you remember the Discovery Pro, that little quad that was sitting over there.
Yeah.
It's also will lift nearly 3 pounds. It'll lift more, but then you're going to sacrifice your endurance.
Oh. What's the weight of it?
It's probably with the battery, maybe pound and a half, maybe pound and a quarter.
Okay.
Pound and a half. No, probably about pound and a half with the battery.
Okay. So
this is all lightweight. Everything, the frames.
So where did you get it? What do you call it?
Where did I get
Shopper Image?
I got it from the little magazine that you get in the back of the seat in the airplane. No, this is actually the logic is ArduPilot Mega, and the name of the company that developed most of the hardware is called 3D Robotics, a company out of San Diego.
Do they make robotics for kids too?
Not
Or
really.
Serious robotics.
Yeah, this is more professional level. It's all you pay for the parts, but then everything, the mission planning, all the navigation logic is all open source, so that's free. But like
There's a community around the world. Of
there's a
people
community
who are
around the world that is
coding for
using
drones,
this, and we've developed a relationship with the software developers to make the mission plan better. So we have a good understanding. You wouldn't want to buy this off the shelf and then just go plug a battery in it and put it up in the air, because
save you a lot of time.
It would save you a lot of time, but the ones that do that, you pay for that.
You pay later.
Yeah, well, you're going to pay later for this if you don't figure it out. The new turnkey ones, you're going to pay for the convenience of turning the key as quickly as possible. The key for this is a little bit harder to come by. You need to spend the time to get to know the logic and get to know. You're building it from the ground up. You're installing the sensors, and then you're tuning each and every component. But once you've done that, you know the platform very well, and you've got a nice tuned product that for a fraction of the price.
God, this must be great. It must be so much fun. Honestly, I mean, I want to put my hands on it. I want to get some tools.
Yeah.
But you know, what I want to do most is take a break.
Oh, yeah.
So we take a short break.
Okay.
That's Ted Ralston, an aerospace consultant, and Chuck Devaney from UH Manoa School of Geography. You're here on Think Tech Talks. I'm Jay Fidel. We're talking about good news for drones in Hawaii. We haven't yet explored how good that news is. Right back after this break.
We want to thank our underwriters.
Hawaiian Electric Company and its affiliates Maui Electric on Maui and Hawaii Electric Light Company on Hawaii Island are deeply committed to the communities they serve.
Galen Ho is a senior executive of BAE Systems, a global defense, security, and aerospace company.
The High-Tech Development Corporation, the state's leading technology agency, attached to the Department of Business, Economic Development, and Tourism.
Castle and Cook Hawaii, with a time-honored legacy that spans more than 160 years and revolves around its mission of investing in Hawaii, creating communities, and providing for the needs of our state.
Hawaii Gas, formerly the Gas Company, a proponent of the Liquefied Natural Gas Initiative, helping Hawaii achieve its transition to clean energy and a better energy future.
Collateral Analytics, a Hawaii-based tech company empowering the real estate industry with greater and faster access to the tools and data they need to make better informed property investment decisions.
I'm Nicole Hori. Thanks so much for joining us on Think Tech.
I'm Maria Kashen. See you next time.
Well, back, we're live. I'm Jay Fidel. Here you are on Think Tech Talks. And we're talking about, gizmos that end all the gizmos as far as I'm concerned. Boy, if I was 8 years old, you wouldn't see this again. It would disappear, I'm telling you now. Anyway, we're talking about good news for drones, good news on drones for Hawaii, because we've had some very, very fortunate luck. And we're going to talk about that in greater detail. But first, can we talk about the specs? You know, Chuck, how long does it fly? How fast does it fly? How high does it fly, and so forth?
Well, the endurance with the payload, we're looking at about 12 minutes on a 5,000 milliamp hour battery, which isn't a lot, but you're also spinning 6 rotors, and the navigation system requires power. So 12 minutes out of this is about all you're going to get. But then you're going to lift a decent-sized payload, of nearly 3 pounds,
Which is almost three times the weight of it.
Yeah, they're powerful little buggers. Like when I spin it up just in testing in the lab, and when I hold it down, I'm like, wow, if this thing would just go right through the, feels like it would just go right through the ceiling. But
what's the RPM on the propellers?
These are 880 kilovolts per kilovolts per minute. So it basically for every volt it will spin 880 times per minute. Is that how that works? I think yeah.
So that's thousands.
Yeah, it's.
Make a racket.
Yeah, it sounds like a swarm of bees when it flies over you. It can get up to. I've had it up very high, but it'll go the 400 feet, which is what we usually operate at, because that's our ceiling. But
you could take it higher.
I could take it higher. I could take it probably very high.
How fast? Wait a minute. What's that? What's very high?
High enough to take a big picture. It'll fly maybe 45 miles an hour.
Oh.
In one direction, which is not good for photogrammetry, because in order for it to achieve that speed, it's got to pitch so far in one direction that unless you have a really nice gimbal system.
But you can pitch it, and that's the way you actually have motion.
That's how it works. Yeah, it dips one way, and then it applies power to the back ones and takes a little bit away from the front ones, and that's how the logic works, and that's also how it keeps itself stable.
Yeah. And is it waterproof? I mean, if you flew it in a rainstorm, what would happen?
Well, it would probably work for a little while. Maybe the telemetry might get wet, and that might not work after a little while. The motors would eventually stop working, but I think that they can handle quite a bit of water.
They would short out, is what would happen. I mean,
they're magnets.
The magnets are exposed.
Yeah, and any of the exposed wires and stuff would eventually probably short out. Yeah, and then the ESCs, which are sealed. It's not designed to be in the rain. It would probably, if you had it up in the air and it did start sprinkling and raining a little bit, you'd probably have enough time to get it down off the ground and get it put away. The biggest thing is salt water. You don't want to dip it in salt water.
Oh, that would
it's
really
done.
finish it. So,
But
so
yeah,
what
that would-
about, I mean, suppose it's up there and it runs out of juice. Does it have a homing
It does.
picture
It
kind
has
of
it
thing?
has several fail-safes, two of which we have enabled. If it loses GPS for an extended period of time, it returns to launch and lands. If it falls below a certain voltage level, it returns to home and lands.
And it has enough to do that.
It has enough to do
calculates
that.
that as
It
it's
figures
flying.
it. Yeah, it's all pre-programmed. We already know that.
Yeah.
It returns it, and you can tell it to just land if you want. If you say, okay, don't come home, just wherever you're at, just go down to the ground and land and de-arm.
Yeah.
There's also it runs off a ground station, but intermittently you'll lose telemetry. There is a fail-safe for that, but since we're line of sight, with this we don't really use that because, like I said, if it does lose communication, we don't.
One
want
of
to
the things that I think people have to understand is that different drones for different folks,
Exactly.
different drones for different functions. So you're in the School of Geography. You mentioned photography. This takes pictures. Is that what this is?
This
designed
is
to do?
designed to take pictures. It's designed to take pictures just based on whatever the pre-programming is. We usually do trigger by distance. You can also hover it over an area and take pictures. You could put a first-person view over the top or on the bottom of it or on top, and then you could do like a top-down surveillance type application. We met with some individuals who are interested in converting this platform into something that can deliver a payload, like a medicine or ER goods or something that needs to get into an area that can't be reached or reached easily.
Did you meet with Amazon yet? Well, let me shift gears. So is this interesting to the effort to make an industry of drones in Hawaii? Where does this fit?
I think it fits in two areas. First of all, as Chuck mentioned, the UAV itself isn't the end state. The end state is the application of the information collected by the sensors. Those could be true color, they could be infrared, they could be radiation sensors. Sooner or later, at some point in time, they're going to be LiDAR.
There's going to be LiDAR. It's coming.
And so
What's
there's
LiDAR?
it's a very high resolution way to get landforms and
Light detection and ranging. It's a laser that scans
Laser, yeah.
and it takes
the
a,
radar.
Okay,
takes
I've
returns.
heard of it.
So there's all these sensor types are emerging. Miniaturization is what makes them work in this environment, and high reliability is what the model airplane business has generated. So they all are converging on this functionality at low cost.
That's another thing that people have to understand. In the old days, with manned aircraft, you could have it big. You wanted it big. You wanted it big everything. And they got
camera was
to
big,
get bigger,
everything had
bigger,
to be
bigger.
big, yeah.
Now with the drones, you want it smaller, 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 but the functionality is mind-boggling.
Mm-hmm.
And this is the kind of thing where we will see them develop this size or even smaller going forward.
Well, and we're paced by the sensor development. Sensor development and the use of the imagery when you're done is what's all about. So in Hawaii, we certainly have a knowledge of the Pacific topography and Pacific needs and Pacific issues. We understand rain, we understand salt immersion, we understand a lot of things that are challenging. And that could be brought forward into design needs and design requirements to make these miniaturized systems work. We have the microsat people up at UH, and they understand small sensors that are really reliable because you can't go up and service them. And so taking that information and fusing it into the evolving air platforms is useful. The camera technology, getting cameras, take the excess weight out of cameras and make as they get smaller, and then all the various what's called GIS analysis, geospatial information systems are used to pry apart the information and put it back together in some different fashion. So, in the case of a natural disaster, you might want to go in first and understand what you have for the big structures, the bridges, the roads, the places to land the helicopter, get a big picture in a short time. Then you want to go back and look more detailed at specifics so you can calculate whether a building is damaged or if a power line or water line is out. And then you want to get even closer down and get things about people that in terms of injured people and such. So there's like 3 different layers here. And again, miniaturization, the application of intelligence.
What I get from you though, Ted, I mean, and this is sort of a realization for me, is that we're only beginning. This is an open area. This is carte blanche. There is no single manufacturer making the standard for the industry. There's lots of manufacturers, and a lot of guys do it at home in the garage. and all these pieces and accessories and sensors and whatnot, they're all in progress. They're all being built and designed, and there's a new one every minute, and all over the world, people are building this stuff. So in terms of an opportunity for Hawaii, it's huge. It's huge because you know that in a year or two, these things will be very different.
Well, the opportunities here, first of all, these items are getting smaller and smaller, and shipment becomes less of an issue. We're not talking about shipborne shipping, we're talking about building cargo on an airplane. And so we become free from that constraint. The real end game is going to be, again, in the analytical software that is used to cognate and extract information from what you're sensing and give command personnel an idea of what the right thing to do is. In fact, the airplane itself, or the helicopter as the case may be, will probably end up being commoditized, but the software will continually emerge.
Yeah, well, so it's like that. I don't remember if we talked about this before, but UH has a port and harbor security vehicle operating in Snug Harbor right now. And they rolled it out, and they're actually licensing it for manufacture by a manufacturing company on the mainland. They're going to make money with that. But what it's built, it's exactly the same thing. It's a platform built locally, fiberglass. It looks like a pontoon affair, but you know, it's got a pretty hokey look to it. Yeah, right. But what's interesting is the sensors. You know, the sensors are very sophisticated, and the analytics for the sensors are very sophisticated. And so, you know, UH has created a vehicle that will be useful all over the world in terms of port and harbor security, and will, you know, not be risky for anyone. You don't have to fly it or drive it yourself. You can do it by remote. And so, I mean, another parallel that, so the School of Engineering is involved in the harbor security vehicle working sensors. The same people, the same idea, the same kind of research would be useful with this.
Absolutely right. A good example in not in harbor security, but in what's called precision agriculture. Understanding how best to manage your crops, water consumption, fertilizer, and time to market. Invasive weeds and such, and management of all that. Farmers using something like this. Again, it's the airplane is just a collector of information. It's the software that provides the guidance. So those are the kind of things that are available. Now the other piece where we're talking about the benefits to Hawaii is in the world of modeling and simulation. One of the issues that will come forth
modeling what?
Modeling UAV operations, modeling them and then simulating a UAV operation in conjunction with air traffic.
Like flight patterns, like that.
And
weather
and
conditions,
throw in the weather,
kind of
throw in
stuff.
a different location, dial up Africa, for example, if you want, instead of Hawaii. But the world of modeling and simulation is going to be the key to getting these into the world. And so Hawaii has a lot of capability there, especially with the supercomputer on Maui. And there's opportunities that are yet to be harvested.
And we could do it here. And we could write that software in our jammies at home, and it would be okay. And it's only open source, as you said, so it's not that hard to become, you know, very, very akamai about this area. We're going to take a break, but before we do, I want to just tell you two things. One is, I think we changed the name of the show to Hawaiian Eye in the Sky. It strikes me that, you know, this is not like a weather balloon. We control where it goes. And it's not like a balloon at all, because it can go there very fast, and it can carry enormously powerful sensors on it. And it's, you know, forget about all the, you know, death and destruction of using it for assassinations. The fact is that the 99.999% usefulness of this is in industry, it's in learning what's on the ground about everything. And when we come back from this break, we'll talk about how you've been using it in the Philippines for good purposes, okay? That's Chuck Devaney on my left, way down my left, and Ted Ralston just next to me. Chuck is at UH Manoa in the geography department, and Ted is an aerospace consultant who is wild about drones, all right? All right. This is Think Tech Talks. I'm Jay Fidel. We're talking about the, was it Hawaiian Eye in the Sky? We'll be right back after this break.
Aloha, I'm Nicole Hori for Think Tech. For nearly half a century, the Hawaii Foreign Trade Zone No. 9 has brought the benefits of the Foreign Trade Zone program to Hawaii businesses and entrepreneurs. DBET, the Department of Business, Economic Development, and Tourism, operates Hawaii's Foreign Trade Zone program to encourage international business and economic development. The Foreign Trade Zone's mission is to increase the amount of international trading activity in Hawaii, thereby providing employment opportunities for the residents of our island state. For more information, see ftz9.org. I'm Nicole Hori. Mahalo.
We're back. We're live. Me and Ted Ralston, aeronautics consultant, and Chuck Devaney from the geography school at UH Manoa, which does everything. I mean, we had some guests on here a week ago. It was amazing. These guys wrote a paper for the journal Nature about weather changes.
Camila Mora.
Yeah. Oh, I was so impressed. Everybody was so impressed.
Yeah, they do good work over there in Mora Labs.
You guys are amazing. Anyway, that's on YouTube. You can look for that on YouTube, and look at our broadcast list on thinktechhawaii.com. So, you know, we have some amazing content coming from the School of Geography. Anyway, so what's with the tennis balls? I didn't. You know, I mean, thank you for saving our table, but why?
They're easy to see because they're bright, so you can spot your aircraft in the air as one, and they're durable. They've been very well tested on many walkers, and it kind of offers it a nice landing pad, so when it does come down on the ground, it doesn't jar everything because vibration happens. Just kind of takes care of it.
And when you're done with the drone, you can have a set of tennis and
yeah. Yeah,
aside from the holes, they'd be very useful.
Yeah.
So you went to the Philippines with this thing, using it for humanitarian purposes. Or was it this one or another?
This was not the one. This will be the one. This will be one of a few different platforms we'll be taking back with us. The first one I took was more of a commercial, off-the-shelf, borderline toy.
What do they say at the Immigration and Customs desk there in the airport in Manila when they see this kind of stuff in your suitcase?
They ask a lot of questions. They wonder, by the end of it, they wonder how they can get one themselves. You know, there's usually guys that are like, you know, in the same thing. It's like, wow, you know, if it wasn't this, it'd be Legos or something.
Sure.
You know, playing with toys.
As long as they don't wonder whether we can get this one from you. You know?
That is a concern. I just kind of go in, somewhat fearless and just say, hey, this is going to go to this particular university and it's going to be for this benefit. And if you, use what you're going to be using it for as, your whatever means of getting through, then they usually let you right through, and it's typhoon relief.
Yeah,
so
good point.
You just let them know, hey, this is we're using it for this, and this is what it's for, and they're like, no problem, thank you.
So why did you go last time, and what's the follow-up trip? What's your program?
Well, this last one was very on a whim. Ted contacted me on a Tuesday, and I was on a flight on a Friday with two of the drone aircraft, the DJI Phantom.
They break down. You can put them in a suitcase.
It's a lot smaller. Yeah. If you remember the white one that was sitting over here,
that was much smaller.
It was a lot smaller than that, but a fraction of the capability. Yeah. So we wanted to go in there with something that was cute, something that was very non-invasive, and something that can handle and are not afraid of losing in the event it gets confiscated or stolen or broken or whatever. Yeah. And
but you carry a kit of tools with you.
Yeah, I do.
So you can fix everything and tune and adjust and what have you.
Mm-hmm. All of that stuff. But these ones were kind of turnkey, out of the box type platform. So we just retrofitted our camera to it and just did sort of proof of concept. Let the local municipalities see it, handle it, see the product that we're able to generate from it. And we also were able to talk with officials at higher levels.
What were you looking
Philippines
for?
Air Force.
You're looking for geography or what?
We are very much so looking for geography on so many levels. You're looking for topography, you're looking for the human condition, you're looking for social breakdown, building structure, you're looking for places where emergency management officials can actually go in and set up shop. Where can we land an emergency helicopter if we need to? Where is there power lines? Where do we see fires? And where do we see blue tarps? Is another one that we're interested in looking at. Where do we need to drop medicine?
Blue tarps? Why do you need to know about blue tarps?
Blue tarps are usually what you see on the ground as shelters in the interim. So FEMA arrives, they have these kits that go out, and it's basically a blue tent, and it comes with.
So somebody's living under the blue tarp.
Yeah, then you can start to see aggregation of people happening, and then you can say, okay, how many people are living in this area? Also, you can look for rooftops. That part of the deal is, in the event of a natural disaster, each household gets a certain amount of tarps, which are normally blue. So we can then do some sort of supervised classification and determine, okay, here's where all the blue tarps are. This is how many people are there. Maybe we should think about sending somebody down there with some.
Okay, so it's you and somebody else? You have other people when you go on these trips?
Yeah, we can set it up with 2-person crews. We'll have one person that will operate it and one person who will observe. We have a ground station where the observer will both observe the aircraft in the air and also the telemetry on the ground.
And with batteries, because you don't know if you're going to have electrical connection at any given place? Or do you?
That is a big problem. We have the capability to charge in a car. If there's a cigarette lighter, we can draw right from the battery with it running, so we can keep charging in the vehicle. We haven't gotten into a situation where we have not been able to charge in the field. Coming up, we are going to probably be using photovoltaic systems that will be able to charge a lithium-ion battery, but very, very slowly. So we're going to be packing a lot of batteries. Yeah. That's definitely a limitation that we have in terms of trying to keep ourselves modular.
And how bulky are the analytic is the analytic equipment? I guess you can do all the analytics you want on a PC, right?
Yeah, for the most part, depending on the type of product we're going after. Some things are more computationally intensive than others. We have the capability to do some processing in the field to get some stuff in the cloud as quickly as possible, but most of that heavy lifting will be sent off to other labs that can do it much faster.
So if you get a good location and you get high enough, you can see miles in every direction.
Right.
You can ask all the questions you want.
Right, you can see a lot in every direction. Basically from about 400 feet, we're getting a snapshot of about a football field-ish. So
then you can send it away.
Well, we get overlap. We move it. Yeah, then we can send that away. We can process it to a certain level, like I said, in the field, so we can get something quick. For the first ones on the ground, 12, so people can see what's going on the ground within. I'd like to see people getting data within 18 hours would be nice, wouldn't it? 12 hours, but that'll be on us.
You fly it in patterns.
Yep.
Cover a certain one on a 50-mile square area.
Yeah, we would then just set up a grid and just program it to cover that grid, and then we'll just take that information and then we'll start a mosaic process and try to have it geospatially referenced, and also develop a surface model of the area and then get that into the cloud as well. But a lot of that takes a lot of computational intensity. So we do have laptops that are capable, then it's heavy. You have that in the field as well. So if we can take that information and move the heaviness away from us into another area, then we can then continue and just, it's going to be a system. It's going to be a complex system where it's going to be the movement of a lot of information.
But it's graphics. I mean, you're taking pictures, taking snapshots, taking movies at all?
We're taking video. Yep.
Really?
Yep. We have a DVR that shoots a first-person view, and
so
it also has an all-screen.
What kind of DVR do you use, off the shelf or what?
Yeah, off the shelf. Obviously.
Really?
Yeah. It's I built my ground station consists of a 7-inch screen and with a box on the back that has all the electronics I need inside of it. That feeds into a laptop with telemetry, first-person view, and then a set of goggles, and then with a HUD, and then we can see when the pictures are being taken. We can, to a certain level, see what the.
So what hangs on the drone?
Well, the camera.
What camera is it? Is it an off-the-shelf camera?
Yep. Yeah, it's been hacked with CHDK.
And you can operate it, you can start it and stop it and all that. That's impressive,
But where you were a few minutes ago is a really important issue. It's the data arriving in some form that's useful by people who have to make decisions. That is really the end state. So Chuck's talking about the workflow to get from the raw imagery collected here through permissible boundaries and then get it into the hands of folks who have to make the right decisions.
Yeah.
But not allow the data to get into the wrong guy's hands.
Yeah.
I mean, terrorists would love to know where there's damage and such, because they can use that as a point of entry.
Now that happened. You remember that? That happened early in the drone development. It was in Iraq, I think, or no, it was in Afghanistan.
Was it Iran where they took a drone down?
No. What they did is they found software that would intercept the signal. And so everything the drone was sending back, the enemy was getting. Wasn't that something?
Yeah,
and it was very embarrassing for DOD.
Yeah.
But let me take a break now while we, sort of get over that embarrassment.
Okay.
And then I want to ask you what all this means in terms of developing an industry. This is very encouraging. What you guys are doing, developing best practices and systems that will be useful in many, many ways. You're just touching the surface, but you're sort of sending back, systems that we can all use for other things. So I like Ted's view after we come back about exactly what does this foretell in terms of developing, a workforce and an industry here that can take it to the next level. Okay, that's Ted Ralston I'm talking about, aerospace consultant. The guy who's been telling you about the drones is Chuck Devaney from We need a break. School of Geography. This is Think Tech Talks. I'm Jay Fidel. We're talking about drones in Hawaii. We'll be right back. Aloha, I'm Jay Fidel. This is Think Tech Hawaii, broadcasting live from the Pioneer Plaza in downtown Honolulu. We raise public awareness about tech, energy, and globalism in Hawaii. Technology is critical to our state. A vibrant tech sector will give us new prospects in the global marketplace and will offer great careers and make our economy more resilient. Streaming live on Ustream and Spreaker, ThinkTech allows its hosts and guests invaluable opportunities to report important events and discuss important questions, and to be heard here in Hawaii and around the world. You can find links to our live streams on thinktechhawaii.com or on our mobile website, m.thinktechhawaii.com. And you can see our archive on YouTube. It's all just a click away. We want to do whatever we can to keep Hawaii relevant, connected, and thriving in the complexity of the 21st century. We hope you will help us in those efforts. Tune in today. This is Think Tech. I'm Jay Fidel. Okay, we're back. We're live. We're at Think Tech Talks, talking about good news on drones for Hawaii, or the Hawaiian eye in the sky, so it's whatever you like. With Ted Ralston, aerospace consultant, and Chuck Devaney, Manoa School of Geography. And we've been talking about, the good news from the FAA. You'll have to articulate that a little bit, exactly what that good news is. And the good news about, the level of our development and use of drones right now, right here, and in the Philippines. What is the good news, Ted, and how do we take what Chuck has been saying and make it into an industry here now?
Okay. The good news is two things, actually. The FAA has published its roadmap that we talked about a little bit before, but whether we like the roadmap or not, what it has in it is all the requirements for research and development, and there's no reason those can't all be done here. Not that we will do them all here, but they all fit within the knowledge base we have in the local university system, and I think our perception and point of view in the islands is stronger than, say, in Nebraska or someplace where all you're doing is agriculture.
We've been designated a test site, right? This just happened, yeah.
That's the other piece of good news. And
tell them about it. What is it? What does it mean?
That was announced like 2 weeks ago, as I recall, and the University of Alaska program, of which Hawaii is a component, and so is, I think, Oregon, was one of the 6 sites selected. And we'll know in a couple of more months what that really means, because there's a lot of management of that future situation that has to be done. There's a lot of coordination between Hawaii, Alaska, and Oregon, and it'll take 6 months or so to get that all sorted out.
What it means, we're on the field.
We are
a test site. Yep. We're one of how many test sites in the country?
We're in the bus going to we've got the football team in the bus, and we're headed to the stadium. And so
and one of very few states.
There's 6 total.
6 total, and we are one of them. So, and they chose us, I guess, because we were a good state to test on drones and to develop drones. And wow. Okay, so assuming we have the opportunity now really to, grow and develop this thing and to become, very akamai and famous about it, what do we do?
Well, long before the specific work scope and such gets defined between the organizations, the research, again, I just come back to the research because that doesn't require a factory, it doesn't require anything but a well-considered electrical engineering department and mechanical engineering at university, and we got that. And so taking this exact report, this FAA Roadmap, and decomposing the research requirements into things that make sense of what we're already doing with microsats and communication systems and such in this environment, in this tropical environment, would give us a whole educational career right there. So you could almost think of an educational development path that has multiple components to it. We can even include the privacy issues with the School of Law. So there's no end of future research needs that could be fed by us.
Yeah, we're only scratching the surface.
Exactly.
Anything goes. I mean, you can
Yeah.
think of new issues every minute about how we could contribute and build best practices and equipment and whatnot. I mean, I can go down to the Department of Commerce and organize an LLC right now and say I want to build drones and I want to get into business. I want investors. I'm going to hire a couple of coders to do the analytics. I'm going to hire some guys to make them or make them better. I mean, it's all out there
And there's
for us.
another advantage I think we've got here as well. We don't have a legacy business of aerospace products here. We don't make airplanes or helicopter or anything, so we're not stuck in that track.
Right.
We're free
We're
to
free.
think in a different way to move forward.
Yeah. So, I mean, Chuck, this could mean that you do something other than straight academic. I mean,
Yeah, I might have to graduate, huh?
One of these days I'll have to join the workforce, right?
Yeah, I don't know.
but I mean, I think, the question I put to both of you, is there money in it? I mean, it seems like there's a lot of good reasons to do it because somebody is going to want to buy this stuff.
I think the answer is yes, there's money in it, in many ways. First of all, let's just assume that we go forward in a way that Hawaii has a reasonable stake in the state FAA test site. In addition to the specific testing that's done, there could be 20 times that in terms of non-certification testing that the various manufacturers want to do to make sure they're ready when they go and apply for certification. The analogy is your car testing, your safety inspection for your car. That's a small piece of income. The real income is in the engine and transmission overhaul and things like that. So we could get into that side of the game, and then the testing part is the smaller part of it all. So there's that.
The other thing that comes to mind is that we have from early in Linda Lingle time, and I guess it was her way of sounding like she was favoring the tech industry, was getting the high school kids involved in robotics. And so she got connected with robotics companies on the mainland and developed all these programs with robotics providers and competitions and what have you. And now my observation is we got a pretty robust program in a lot of the high schools around the state. Mm-hmm. There's a lot of kids who, would understand exactly what you've done on this drone and could do it also and could give suggestions for, innovative improvements. And so I think we already have the basis of a workforce. So it's not only the university, it's all those kids coming out of all those programs.
Absolutely.
In fact, it would really be interesting to take a couple of those programs and have them take a look at how they would handle the FAA Roadmap.
Fresh look.
And not have us legacy in it, but have them take a look at it. And what a way to get their interest up. In particular, the issues we're going to be having to deal with are reliability and predictability, and the issues that evolve so that when you say you're going to do a mission of a certain type in a certain place, it happens. Yeah. And it doesn't happen the wrong way. Get the kids involved in that. All robotics are going to need that sooner or later.
Yeah.
And the higher the consequence of the operation or misoperation, the higher their need for reliability. And so there's redundancy, there's software that observes and manages the flow. These are all opportunities that are right in front of us.
So, Chuck, if you had a chance to talk to some high school kids out there, say there's a class of high school kids watching this, what's your advice to them about the possibility of being part of the workforce and having a career, actually, in one or the other disciplines involved in drones?
As a high schooler, first of all, do your homework, stay in school.
Thank you.
Yep.
And stay away from bad substances.
And stay away from bad substances. Exactly. No. A lot of these guys that are good at flying drones, and I think I've learned this about some of the military people who are flying drones, they're gamers. High school kids like to play games. This is like
hand-eye coordination.
Absolutely,
all that. Yeah.
absolutely. So they're going to have that upper hand, that's for sure. We'll have a good basic understanding of electronics, and I think that they incorporate that into maybe some, like vocational type classes they might have in high schools, and the robotics as well. You know, they're going to have an understanding of current flows and, you know, polarities and stuff, so they'll be able to manipulate servos and turn motors the right way and so on and so forth. So
I can see how much they would love this stuff.
yeah, so yeah, I think you're flying remote aircraft as, you know, something they used to do for fun, but now it has application, it has purpose. And
We got to close up, you guys. So let me give you the last word, Ted. What would you say to the community in general, including the government, state government, about this? What does this mean to Hawaii's economy?
It means a future sustainable business framework that doesn't require large infrastructure and doesn't depend on a legacy past. So none of the issues that we always concern ourselves with are present here. We're talking about software, we're talking about cognation, we're talking about reliable systems, we're talking about training. Training is another big issue here, because training is the sinew that holds all of it together. So there's many, many directions we can go. And I think what we just need is to get our vectors lined up, consolidate our thinking, and begin laying out what some of these agendas look like.
Well, as we go down the roadmap, we'll check back with you guys again. Ted Ralston, aerospace consultant. Chuck Devaney, UH Manoa School of Geography. This is Think Tech Talks. I'm Jay Fidel. We've been talking with them about drones for Hawaii. We'll be back shortly with The Art of Life with Willow Chang, and then The Millennial Entrepreneur, and finally, to close our week of programming, The Next Best Thing with Attila Suresh. Aloha.